Today we're going to continue talking about imaginary and complex numbers. Yesterday, remember that we left off by talking about simple addition and subtraction, basically just adding and subtracting like terms. It gets a little trickier though when we want to figure out how to multiply complex numbers. You see, when you're multiplying, you're going to end up doing the distributive property, sometimes the FOIL method, depending on what you're given. And, it gets a little more complicated, just a little bit. So let's multiply 2 plus 3i times 6 plus 2i. 2 plus 3i, 6 plus 2i. Now, again, it's a multiplication problem, which means that you're actually going to distribute. In fact, you're going to end up distributing everything in the first parenthesis to everything in the second parenthesis. So we would start with 2 times 6. Now, of course, that's going to be 12. But 2 times 2i, yes, you're allowed to do that. That's going to equal 4i. So again, 2 times 2i is going to give us 4i. Well, we need to continue to distribute, so we're going to multiply this 3i. We're going to distribute this 3i to everything in the parentheses. So that's going to be 3i times 6. And again, yes, you're allowed to do that. That gives you 18i. And then you're going to take 3i times 2i. Now, 3i times 2i, it's actually kind of the heart of this problem. You see, the 3 and the 2 certainly give you 6, but the I times I, now that is going to give you I squared. Why is that so special? Well, do you remember from yesterday that I squared actually has a value? Yes, I squared is equal to -1. So really what we're looking at here is like 6 times -1. 6 times -1. Well, if you simplify that, you're going to end up getting, -6. So 6i squared is the same as 6 times -1, which ends up equaling -6. Now, by the way, these other numbers here, I can certainly simplify them, especially this 4i and 18i, which is going to equal 22i. But the cool thing here is that this 12 and -6, now they can actually come together. And of course, they equal 6 with the plus 22i. And finally, we have 6 plus 22i. Let's try another one. Again, we're multiplying. And many of these problems is going to look like doing some type of distributive property. I don't actually have to do like a FOIL method on this problem because, well, there's only a single 2i that's going to get multiplied to the 3 minus 5i. 2i times 3. Yes, you're allowed to multiply those. That gives you 6i. But 2i times -5i, now that's special because 2 and -5 multiply to be -10. But the I times I, now yes, that multiplies to be I squared. What's true about I squared? That's right, it equals -1. So really what I have here is like -10 times -1. -10 times -1. And so that ultimately is going to come out to be 10, or positive 10. With the 6i, we end up with 6i plus 10. So you see that when you multiply, it seems like we get I squared, at least we've gotten in the last two problems. Whenever you get I squared, it's the same as -1. And of course, when it gets multiplied, it can change the value of the number in front. You want to try one? See if you guys can simplify 7 plus 3i times 7 minus 3i. This would be a good example of like a FOIL method, meaning that we're going to multiply 7 times 7, as well as 7 times -3i. And then you're going to multiply 3i times 7, and 3i times -3i. 7 times 7, of course, is 49. 7 times negative 3i is negative 21i. 3i times 7 is 21i. That is positive. Now, how'd you do with the last one? 3i times negative 3i? How many of you are ready just to write plus 9? Well, if you say, I'm ready, then you may do that. If you're like, why did you get plus 9? Remember, you end up with 3 times negative 3, which is negative 9, and then I times I, which is I squared. Now, negative 9 times I squared is like negative 9 times negative 1. Remember that I squared equals negative 1. So, negative 9 times negative 1 is positive 9. Look at these numbers. They actually cancel each other out. So it looks like I get 49 plus 9. Wait, just like 3 regular numbers here, or 2 regular numbers, which add together to be 58. Yes, my final answer is 58. So I multiplied 2 imaginary numbers that I started with, but I ended up with like a real answer. That's what's going on. That's how you multiply complex numbers. Next, we're going to divide complex numbers. Now, to be honest with you, dividing is a little more complicated simply because now we're going to be talking about fractions. When you have a fraction, you're going to end up having to multiply by what's called the complex conjugate. Sounds pretty tricky. Well, first thing to understand is what's a conjugate? And the answer is, it's like this last problem. You see, 7 plus 3i and 7 minus 3i, they weren't really opposites of each other, but they had an opposite sign. And so when you have like a binomial, like 7 plus 3i, and then you get another binomial that has just the opposite sign, 7 minus 3i, we call those conjugates. And look what happens when you multiply conjugates. You guys are going to come to learn that when you multiply conjugates, you always end up with a special result. You end up with a regular real number. So, it appears that to do a division problem, we're going to have to use conjugates. Now, written out with some symbols, we would say that that would be like having a plus bi, but then a minus bi. See this idea of having a plus and a minus. Apparently, we're going to have to multiply the fraction by the complex conjugate of the denominator. Okay, so what that means is that we're going to look at the denominator to try to determine our complex conjugate. Before we actually do a division problem with a complex conjugate, just want to make sure that you understand what I mean by a conjugate. If I decided to give you 2 minus 4i, the nice person that I am, so I give you 2 minus 4i, the conjugate of that would be 2 plus 4i. Yeah, all it is just having the opposite sign. So 2 minus 4i and 2 plus 4i are conjugates of each other. What if I gave you negative 3 plus 2i? Negative 3 plus 2i. Could you come up with a conjugate for that? Now be careful, the only thing that you change is the addition-subtraction sign. So it's still negative 3, but now minus 2i. So those would be conjugates. Looks like I'm supposed to use a conjugate to be able to divide 4, having trouble today. Start over. We're going to use conjugates to divide 5 plus I with 2 minus 4i. Okay, now, 2 minus 4i. I feel like we just saw that on the previous screen. So what we're supposed to do is we're supposed to multiply by the conjugate. Okay, well that's going to be 2 plus 4i. So we multiply by the conjugate. you have to do it to the top and the bottom. You see, when you have a fraction, if you're going to end up starting to start to put things into the fraction, you got to put those things in the numerator and denominator. Okay, so I'm going to multiply the top and bottom by 2 plus 4i. Now, what have I actually done here? Well, I've actually made two FOIL problems, two distribute problems, right? I mean, the only way to actually multiply or start simplifying this problem is to take the 5 and multiply it to the 2 and multiply it to the 4i. But then I have to take the I and multiply it to the 2. That's going to be 2i. And then I times 4i. Now, who's ready to write this simplified? Remember, I times 4i is 4i squared. But we talked on the previous page that that's going to be like 4 times negative 1, which is the same as negative 4. I'm going to encourage you guys to write it as negative 4 as soon as you can. We're not done. We still have to multiply or FOIL or distribute the bottom. So here we go again. 2 times 2, that's 4. 2 times 4i is 8i. Negative 4i times 2 is negative 8i. What's going to happen with those numbers? And then negative 4i times 4i. Now be careful here. Negative 4 times positive 4 is negative 16. I times I is I squared. Negative 16i squared. That's the same as positive 16. So what's going on here? Well, what's going on is that we're creating a different looking fraction. By the way, if I combine some like terms up here, I'm certainly allowed to do that. I would get 6, and then add your i's and you get 22 of them. So I get 6 plus 22i. Down in the bottom, as we already talked, it looks like these are going to cancel, and I end up with just 4 plus 16. I end up with just 20. Now, we would say that that is more simplified, mainly because there's no imaginary number in the denominator. There's just a regular real 20 in the denominator. 6 plus 22i all over 20. Now, that answer's acceptable, and I would give you credit for it. It just so happens that each of these numbers could simplify with 20. That is, if I did a heart method, I could actually reduce 6 over 20. I could reduce that by 2's to be 3 over 10. And I could reduce this other one by 2's to be 11 over 10. And so we end up taking the original, or what was our answer before, and now we get some smaller values. The other thing that's true is that I could have just simplified these numbers without splitting it, without doing like a heart method. I could have just kept it as one fraction. So I still get 3, I still get plus, I still get 11i, and they're all divided by 10. Both these answers down here would be right. Now, dividing, it's a little different. It's a little harder. Let's try it again. I want you to be able to divide, and honestly, all you have to do is multiply by what's known as the complex conjugate. Now, if you're looking at 8i and you're saying, well, what's going to be the conjugate? All I need is to multiply by the opposite sign. And this one is a positive by default, so that means I need to multiply by a negative 8i. Now, if I'm going to multiply the bottom by negative 8i, I got to multiply the top. We would consider this to also be the conjugate. All it is just having the different sign, the opposite sign on the imaginary number. This problem is actually a little easier because I only have a single negative 8i. And the single negative 8i is going to distribute to both of these. Now that'd be like 3 times negative 8i is going to be negative 24i. And then it's going to be like 7 times negative 8, which is negative 56. But again, I get that I squared. Negative 56i squared. Who's ready to write that simplified? We'll do that in the next step. How about 8i and negative 8i? 8 and negative 8, negative 64. I times I is I squared. Again, who's ready to write that? We'll do that in the next step. So, the cat's meowing over there. Do you hear him? Negative 56i squared. Negative 56i squared. That's the same as negative 56 times negative 1. Negative 56 times negative 1 is positive 56. And then negative 64i squared, same thing. That's like taking negative 64 times negative 1. It's going to be the same as positive 64. Now, this answer that we got, this is good. If you can get to this answer, that's great. That's good. But if we want to be great, we notice that there's actually a number that divides into all of these. And honestly, we can reduce this whole fraction by the number 8. Yes, we can reduce each number by 8 since it is common to all of those circled numbers. So we get kind of a smaller, simpler looking answer, which we would say is, wait a minute, hold on a second, we're reducing by 8. So that means we're going to end up with negative 3. All right, so we simplified or divided every number by 8. All right, we get this smaller fraction, which it's even a better answer. Trying to help you guys work towards greatness, so I do want to show you that simplified fraction. See if you can do one. See if you can try to divide 6 and 3 plus 5i. You should be multiplying the top and bottom by the conjugate. How you doing? That would be like a 3 minus 5i. Okay, it's just the opposite sign. Up here in the top, it's actually quite simple. You just take 6 times 3. 6 times negative 5. I is negative 30. I. Now in the denominator, I'm multiplying conjugates together. When you multiply conjugates, special things happen. The special things that happen is that these numbers in the middle, which are going to come from these two distributes, they're going to cancel out. But there are other numbers that you get. You end up getting 3 times 3, which is 9. Now remember, you're going to get these numbers in the middle, negative 15i and positive 15i. I guess I actually had them in green, didn't I? So we get negative 15i, we get positive 15i. I'm showing you how those are going to cancel. Maybe you're saying, can I cancel them right now? You certainly can. Don't forget that 5i and negative 5i is negative 25i squared. So, nothing changes in the top. I still have 18 minus 30i. In the bottom, though, my 15i's are going to cancel. My negative 25i squared is the same as negative 25 times negative 1, which is going to come out to be positive 25. 9 and positive 25 is 34. So I have 18 minus 30i all over 34. Hey, once again, there's a common number. There's a number that divides into both of these. What common number is that? Wait a minute. 34? How about, 34, right? 9 plus 25. All right, I'm not sure why I had second thoughts on that. But yeah, there's a common number that divides in all these. I'm pretty sure 2. 2 divides into all these numbers. So in effect, I can reduce everything here by 2, leaving me with smaller numbers, smaller values, and a more simplified answer. We would call it 9 minus 15i all over 17. Dividing. You have to multiply by the complex conjugate. And when you multiply by the complex conjugate, it looks a little messy when it's behind all that math work, but it causes the denominator of your fraction to become a regular real number. And we like regular real numbers. They're considered more simplified. Well, you're now ready to do the other 2 sections in the homework. That homework sheet, let's see here, it should be the backside, sections D and E. So you're trying to do sections D and E in the homework sheet.